Linear systems by elimination. So the last method to solve linear systems that we're going to take a look at in this course is elimination. And elimination is like an old school addition or subtraction question. So like before in the previous methods, we're going to work through some steps in order to be able to solve these equations more efficiently. So the first thing you want to do is to stack the equations. So we're going to line up the variables, x over x, y over y, and equal sign over equal sign. So what this looks like is this. So I have 3x minus 4y is equal to 14. And I'm going to stack that on top of 3x plus 7y is equal to negative 8. So we have the x over x, y over y, equal sign over equal sign. So now what we want to do is we want to add or subtract the equations to eliminate a variable. So we eliminate the variable whose coefficient is the same. So in this set of equations, we're going to eliminate our x variable because they both have a 3. And so we have to figure out, how do I eliminate that variable now? So do I add or do I subtract? So if the signs in front of the coefficients, so the signs in front of the coefficient is what we're looking at to determine whether we need to add or subtract. So if they are the same, then we subtract. If the signs are different, then we add. So the way I like to think about it is the word same and subtract both start with the letter S, and the word different and add both have D's in it. So is the coefficient in front of the variables the same? Yes, they are in front of the x's. Is the sign in front of that coefficient the same? So are these both positives or both negatives? And yes, they are in this case. So we are going to subtract. So now it's going to look like this. So I'm going to rewrite this so that I have my equations stacked one over top of each other, x over x, y over y, and equal sign over equal sign. And now I'm going to do this as if it was a addition or subtraction question. This time I'm going to subtract. So 3 take away 3 is 0. So these guys disappear, our x's, which is what we want because we can only solve for one variable at a time. And then I have negative 4 take away positive 7, which is the same as negative 4 take away 7, which is negative 11y. And that is equal to 14 take away negative 8, which is the same as 14 plus 8, which is 22. So now I have eliminated one of my variables by adding or subtracting. In this case, I subtracted because the signs in front of my coefficients were the same. They were both positive. And now I have an equation that just has one variable. So step number 3 is to solve for this variable that's left over. So I'm going to rewrite my step right here. So now I'm going to divide both sides by the coefficient in front of my variable. In this case, it's negative 11. So negative 11 divided by negative 11 is 1, so I'm just left with 1, y, or I can just write y. And 22 divided by negative 11 is negative 2. So the value that I've solved for y is y equals negative 2. So now I'm going to take that value and I'm going to substitute it into one of the equations from step number 1. And it doesn't matter which equation you put it in. You can put it in the first one or the second one. You're going to get the correct or the same answer for that value of x in this case, regardless if you put it into one of them. So you pick whatever one you think is easier. Let's put it into equation 1. So 3x minus 4y is equal to 14. So I'm going to substitute the value of negative 2 in place for my y. So I have 3x minus 4 times negative 2 is equal to 14. 3x minus 4 times negative 2 is positive 8, and that's equal to 14. I want to isolate the x, but I first do that by moving over whatever constant is being added or subtracting. And so the opposite inverse, or the inverse operation, is going to be subtraction. So I have 3x is equal to 14, take away 8. 3x is equal to 6. And now I'm going to divide by the coefficient in front of my x. And I do that to both sides because I want to balance my equations. 3 divided by 3 is 1, so I'm left with just x. And 6 divided by 3 is 2. So now I have my x value and my y value, so I can say that my coordinate is positive 2 and negative 2. So in order to verify that this solution is actually correct, I need to do a left side, right side check for both of my equations. And the goal is to show that both of my equations, the left side and the right side, will be equal to each other using the coordinate that I found in step 5 or in step 4. So my first equation was 3x minus 4y equals 14. 3x minus 4y is equal to 14. And my second equation was 3x plus 7y is equal to negative 8. So I'm going to substitute the values in for my x and my y. So 3 times 2, take away 4 times negative 2. 3 times 2 is 6. Negative 4 times negative 2 is positive 8. And 6 plus 8 is 14. So that works for the first equation. Let's see if it works for the second equation. So I have 3 times 2 plus 7 times negative 2. 3 times 2 is 6. 7 times negative 2 is negative 14, and 6 take away 14 is negative 8. So it works for both my equations. So the left sides equal the right sides. Therefore, I can say with certain that my point of intersection is the coordinate 2 and negative 2. So this left side, right side check is a great strategy to use to make sure that you've done your questions correctly. So let's go through 2 more examples. Example 2, we want to solve the following system by elimination. So I have 2 equations, 3x plus y equals 19, and 4x minus y is equal to 2. I want to stack up my equations, so I'm lining up my equations one over top of each other, x over x, y over y, and equal sign over equal sign. So now what I want to do is I want to determine whether I need to add or subtract. And I need to think about, first of all, which coefficient is the same. So the coefficient in front of my x's are different, but the coefficient in front of my y's are the same. So I'm going to eliminate, in this case, my y. So I want to think about that. So I can do that. And I need to think about, do I need to add or subtract? So are the signs in front of your coefficient in front of your y's the same, or are they different? And in this case, they're different. So that means we need to add. So I'm going to rewrite my set of equations, making sure that I'm stacking my equations, x over x, y over y, and equal sign over equal sign. And now I'm going to add these 2 equations together. 3 plus 4 gives me 7x. Y plus negative y is 0, so these 2 cancel each other out, which is what we want. And 19 plus 2 is 21. So now I have an equation with only one variable. So now I'm going to solve for that variable. So I have 7x is equal to 21. I'm going to divide both sides by the coefficient in front of my x. 7 divided by 7 is 1, so I'm just left with x. And 21 divided by 7 is 3. So now the value that I found for x is 3. And now I'm going to substitute that into one of my equations from step number 1 to find the value of y. And as I said before, it doesn't matter whether we're putting it in the first equation or the second equation. In our first example, we put it in the first equation, so let's put it into the second equation. Second equation has smaller numbers, so it might be a little bit easier to solve. So I'm going to use my 4x take away y is equal to 2 equation. And I'm going to substitute the value of 3 into my place of my x. And I'm going to solve for y. 4 times 3 is 12. Take away y is equal to 2. I want a positive value for y, so I'm going to move my y value to the other side of my equal sign. So now instead of subtracting y, I'm going to be adding y, and that will make sure that my y value is positive. So I'm going to have 12 is equal to 2 plus y. And now in order to finally isolate the y, I need to move over this 2 to the other side. Right now it's being added, it's a positive 2, so when I bring it over it's a negative. So I have 12 take away 2 is equal to y, or 10 is equal to y. So you can keep your answer like this. Some of you may really want to write it as y equals 10. Either of these will work. So the solution for my equations, so they were going to intersect at the point 3, 10. So I need to make sure that I've done that work correctly by doing my left side, right side check for both sets of equations. So the left-hand side of my equation is 3x plus y, and that is equal to 19. And my second equation was 4x minus y, and that's equal to 2. So I'm plugging in the values for x and y. So I have 3 times 3 plus 10 is equal to 19. 3 times 3 is 9, and 9 plus 10 is 19. That one works. That's great. Let's do the second one. 4 times 3, take away 10. 4 times 3 is 12, and 12 take away 10 is 2. That one also works. That's what I want to see. So the left sides equal the right sides. Therefore, my point of intersection is the coordinate 3, 10. So one more example. So this example number 3, has an extra sort of intermediate step. And I'll show you what that looks like. So example number 3, we're solving the systems of equations. So we want to find out where these two straight lines intersect. So you'll notice that I've broken up this into step 1a and step 1b because this is going to be very important. So the first thing we want to do is we want to stack the equations. So we're going to line up our variables. X is over x, y is over y's, and equal sign over equal sign. So now we need to think about what variable are we going to eliminate. So are the coefficients in front of the x's the same? No, one's a 2 and one's a 1. Are the coefficients in front of the y's the same? No, one's a 1 and one's a 2. So we need to do step 1b. So does either variable have the same coefficient? No. If not, how can we change one of the equations to make this happen? So we want to either make the x coefficients the same or the y coefficients the same. And it doesn't matter, truthfully, it doesn't matter which one you choose. So we're going to either be multiplying equation 1 by something to make the in this case, our y value is the same, or we can multiply equation 2 by something to make the x's the same. And sometimes we might have to multiply both equations by something to make them both the same. And so that's important to remember. So if you have any questions, especially about example number 3 or any of the questions that might cause you difficulties when you're doing some of the IXL work or even Knowledge Hook, please let me know by throwing your questions up on the discussion board in the virtual learning environment or sending me an email. So we are going to take a look at this one, and we are going to make the values in front of our y's the same. And we're going to do that by multiplying this first equation by 2. So that'll make sure that both of my y values are going to have the same coefficient now. When I'm multiplying it by 2, I have to multiply every single term in that equation by that value to make sure that the equation of that line is going to be the same. So this is what your next step 1b is going to look like. I'm going to have 4x minus 2y equals to 10. So I've multiplied every single term in this first equation by 2 to get 4x minus 2y equals 10. And I'm going to rewrite my second equation right underneath it. There's nothing I need to multiply this one by because now the coefficients in front of my y's are exactly the same. So we're going to now eliminate the y variable. So do we add or subtract? So let's take a look at the signs in front of our coefficient. So the signs are the same. They are both negatives. So we need to subtract. So I'm going to have 4x take away 2y is equal to 10. And then I have x take away 2y is equal to 8. So I'm going to subtract these two equations. 4 take away 1 is 3x. Negative 2 take away negative 2y. So negative 2 plus 2y is 0. So these ones have disappeared, which is what we want. And 10 take away 8 is 2. Now you'll notice here that when I solve for my variable, it's not going to work out as a nice whole number, and that's okay. So that's important to remember as well. So sometimes they'll work out with nice whole numbers, and sometimes they won't. So let's see what that looks like. So I have 3x equals to 2, so I'm going to divide both sides by the coefficient in front of my x. So 3 divided by 3 is 1, so I'm left with x, and x is the same as 2 over 3. So you can keep this as a fraction, which I'm going to do, or if you really wanted to, you can convert that into a decimal number. That's fine as well. So now we're going to substitute x equals 2 over 3 into one of the equations from step number 1. So I'm going to put it into one of my original equations. And it doesn't matter which equation you put it into, whether you put it into equation 1 or 2. I'm going to put it into equation 2 because I don't have to multiply anything by that x. So that's something that you might want to do. Or you could put it into equation 1. That's fine as well. So what I'm going to do is I'm going to substitute this value into my equation number 1, which, into equation number 2, which is x minus 2y equals 8. And I'm going to solve for my y. So this question will force us to think about all of those adding and subtracting and multiplying fraction rules that you may have hopefully not forgotten, but it is a good chance that you may have, so we'll review some of those as well. So I have 2 over 3, take away 2y, is equal to 8. So I want my y value to be a positive y, so I'm going to start by moving my y over so that it becomes a positive value. So negative becomes a positive, so inverse operations. So I have 2 over 3 is equal to 8 plus 2y. So now I want to move over my 8 in order to start to isolate my y. And when I bring this over, right now it's a positive 8, so it becomes a negative when I bring it over. So I have 2 over 3 take away 8, and that's equal to 2y. So you may be saying to yourself, what should I do now? Because I want to, do I want to change this into fractions so that I only have one term before I divide by 2, or do I want to try to divide by 2 first? So I'm going to start by changing my 8 into a fraction so that then I can think about putting these so that they have the common denominator. So when I am subtracting or adding fractions, they must have the same denominator. So in order to make a whole number into a fraction, you place it over 1. And I want to make this the same, the denominator is the same, so I'm going to multiply both my numerator and my denominator by 3. So my next line is going to be 2 over 3, and then 8 times 3 is negative 24, and 1 times 3 is 3. So now I have two fractions where the denominators are the same, and that is going to help me out quite a bit. So 2 take away negative 24, 2 take away 24 is negative 22 over 3. And that's the same as 2y. So now I'm going to divide by my 2. So normally I would write it like I did in step 3, but because I already have a fraction, I'm going to just show that I'm taking this value for 2. Right now it's being multiplied by my y, so when I bring it over, I'm going to divide. So I'm going to have negative 22 over 3 divided by 2, and that's going to equal 1. Now, when I divide fractions, I want to start by turning my 2 into a fraction. So just like I did with my 8, I'm going to put this over 1. When I divide fractions, I change my division sign into a multiplication sign, and I flip my second fraction. So now I'm going to be able to solve this a little bit easier. I can think about this by thinking about how many times does 2 go into negative 22? And that goes in there negative 11 times. So that's one way I could do it. Or you could multiply your numerators and then multiply your denominators. I'm going to use this strategy just to make my numbers a little bit smaller than to proceed. So 2 goes into negative 22 negative 11 times. So I'm left with negative 11 times 1. And then 3 times, this is like a 1 here, over 3. So now I have a coordinate for my y. So my x is 2 over 3, my y is negative 11 over 3. Now I can imagine that you are not so happy with this example because of the fractions. Not all of your ones that you're going to have to multiply to get eliminating is going to turn into fractions, so please keep that in mind as well. So the next thing we want to do, step 5, is to do those left side, right side checks. And this time we're just using fractions. And again, you can convert these fractions into decimal numbers if that's easier for you. Let's keep them as fractions though, just to continue on in this example. So I'm creating my t-charts and I'm going back up to my original equations. 2x minus y equals 5. And my second equation, which is x minus 2y equals 8. So I'm plugging in the values that I have. So 2 times 2 over 3, take away negative 11 over 3. 2 times 2 is 4, 4 over 3, plus 11 over 3. 4 plus 11 is 15. Divided by 3 is 5. So look at that. That wasn't too bad. All right, so let's take a look at the second equation. I have 2 over 3 take away 2 times negative 11 over 3. 2 over 3, negative 2 times negative 11 is plus 22 over 3. 2 plus 22 is 24 over 3. And 24 divided by 3 is 8. So the left side equals the right sides, which is what we wanted. So therefore, we can say with certain that the point of intersection is the coordinate 2 over 3 and negative 11 over 3. If you had converted these into decimal numbers, you might find that your left side isn't quite the same as the right side, but it's going to be very close. So this could be like 4.9. right? So it's very close, because when we're converting to decimals, we are taking away some of those, uh, we're taking away the opportunity for it to be very precise. So keep that in mind as well. So those are 3 examples that you can refer back to. This one with fractions will help you sort of remember those rules with fractions that you would have started to learn in elementary school, and hopefully reviewed in grade 9 as well. As I said, if you have any questions, please throw them up on the discussion board, or send me an email.